Hi, and welcome to day 4 or Thursday of our professional development for APCSA or really any Intro to Java K-12 course. So today we're going to talk about the sticking points around units, what are we on now, 7 and 8, which are array lists and 2D arrays. We've already done static arrays in unit 6, so in the previous video. And then we're going to talk about misconceptions. These kind of go back to unit 5 a little bit around objects and classes and collections. But given that an array list is an instance of a class or an object, some of this kind of blurs together. They'll share those misconceptions around, well, I can't have multiple array lists, I can't have multiple objects. Spoiler alert, that's one of misconceptions. So we'll talk about those later. And finally, we'll get to evidence-based pedagogy. And today we're going to talk about live coding, which we've done a little bit throughout the week, where you've seen me struggle with Python tutor, full of different visualizations, etc. And test-driven development, which is seen mostly in industry, a little bit in high ed, not as popular in K-12, but it's a really interesting and productive approach to get students thinking about the functionality of the code before they start coding it. The thing that just killed me when I was in the classroom was walking over to a student typing away on the keyboard, and you ask, what you programming? I don't know. Like, didn't you stop to think and plan? No. So it's a really good way to kind of let them start typing, but kind of force them to plan what they're going to do. So content, let's get into some of the sticking points. So again, we're in unit 7 and 8, and we're going to talk a little bit about 7.2, just array list methods, sorting, which is introduced in 7.6, and then traversing, just normal 2D arrays, so 8.1. So the first sticking point around array lists is there's this idea of add versus set. And they do slightly different things, importantly different, but slightly different things, and look very similar and sound similar. So add, when you have just the single argument, just adds it to the end of your array list, but you can start to specify which index you want to add it at. And remember, when you put it in there in index 0, everything else gets scooched down. You're not overwriting it, you're adding it, you're inserting it in there. And this can get a little confusing because you can set elements which have the same arguments, index and value, but that's going to overwrite index, in this case 2. And so there's no scooching down. The length of the array list does not change. It's an overwrite. And so just making sure that there is a clear distinction in their head around add, which is insert and scooch, versus set, which is overwriting a value. Just a little bit different, very, very easy to accidentally switch those out, especially given their arguments are the same. Another piece in unit 7 is sorting. They get kind of a preview of selection and insertion sort. It's insertion, right? Yes. And these are just really hard to understand from the code itself. And so they see the code, we're giving them some videos to try to help them visualize it. But as the classroom teacher, this is one of those moments in computer science you can really get into embodied learning, get them active, doing something with their hands. And so CS Unplugged, the classic version, not the new version, has some activities around sorting algorithms where you can have them step away from the computer and try to build that intuitive understanding around selection and insertion sort that before they see the code, because the code is really complex and messy, and the code visualizer, I would say, does a great job of it. But just getting that intuitive understanding before being faced with the code, CS Unplugged is a great warm up. Finding film canisters can be a little bit of a challenge, but basically what they're doing is they have different weighted film canisters and they're trying to sort them without really knowing what's inside, just being able to compare one-to-one on a scale. I've done this activity. Kids think it's really fun. Generally, the students in your CS courses really love puzzles, and there's no syntactical mistakes in this activity. I had them work in pairs, so I didn't have to make as many scales. One of those moments, it's great to be friends with a science teacher. They might have these in a closet and let you borrow them, and they might have something interesting to fill those film canisters with. I just used hardware from kind of the bottom of the robotics lab in the odds and ends bucket. So last but not least is getting into 2D arrays, and probably you could guess the sticking point is the order of row versus column index specification. So is this 3 a row or a column? In this case, it's obviously Owen. Well, oh, yeah, this would be this above. So I have 3 rows and 5 columns because they're different numbers. This gets extra confusing when you do examples where it's like a 3 by 3. Code Visualizer does a pretty good job of it. You can see, okay, there's rows and columns, but it's just really hard to know which way is which. So as much practice as you can get. I remember my high school CSA teacher talking to us about RC Cola, which is a knockoff soda pop product. And that's how you specify the indices in 2D arrays is RC, rows, column, RC Cola. If that helps. If not, you can come up with some other mnemonic device, but something that will stick in the student's head to really understand it's rows before columns. It's so easy to mess those up, especially when you start traversing over them and you have nested for loops. Really implore them to name their loops that traverse over these as rows and columns, just to help keep it straight. All right, so those are kind of the sticky points in the content, really just making sure they have those bits in terms of add versus set and not conflating those. Having a more intuitive understanding of sorting before going into the code because it's so messy. And then the order of those indices for 2D arrays and not mixing up rows and columns. Some really classic sticking points for your students. But there's also common misconceptions that we see in the research literature. And like I mentioned, these are going a little bit back to classes, but specifically array lists are a type of object, so they're pretty relevant. So I see this all the time. I think this was just born out of the examples we as teachers choose. So I have a boat named boat. And so what is the data type and what is the name of the object? And it's super confusing. And we do examples like this literally all the time as teachers, thinking this is good names, but it's going to be a lot more clear to the student. Well, Titanic is the name of the boat. And so you can use a little bit better naming to help this one specifically, but they really get confused about what's the variable name and the object type can get really messy. Only one variable can refer to an array or object type. So this is kind of what I was talking about. They don't think about, I can have multiple array lists. I only get one. I can't have multiple dog objects. I can only have one. They don't think about the class as a template that you can reuse over and over again, or a blueprint you can reuse over and over again. They think you kind of fill out that worksheet or that template once, and that's the one you get. And so knowing you can have multiple of it. Similarly, that you can only have one instance of that class. So this idea that you can't have 3, 4, 5 instances. They also sometimes do something like this, where D2 is equal to D1, thinking, okay, now I've renamed it. Just sort of true. The D2 pointer is pointing to that original D1 object, but D1 doesn't go away. Like, that's still there. It's not really renamed in the way they're thinking about. Similarly, they'll do almost the exact same syntax down here to think you're copying the object. This is one of those things that is just great to put in the code visualizer, because this is such a confusing line for them to understand. But in the code visualizer, it just makes another arrow pointing to that instance of the dog object. And they're like, oh, that's what's happening. It's not a copy. It's not renaming it. It's literally just adding a pointer to the same thing. Objects with the same state are the same object. So if I have a car with these specifications and another car with the same specifications, they're the same object. Well, they have the same values, but they're not the same object instance. And so you can think about this as, okay, well, you can have a car and I can have a car, and they can be the same make, model, color, year, etc. But if one of us crashes our car, your car doesn't magically also break. They're not the same. They're identical, but not the same. There's also this idea that, okay, well, they all go through that same class. So the class must like know about all of the object instances, or the class instances, the objects. So if I make these 3 smartphones, the smartphone class is a collection of all these objects. And it doesn't know that it has this many objects made out of this class. There's no way to get that list unless you make it. So there's just some really interesting thought process around, like, well, it went through the class, so the class must know. Once again, I think this is an artifact of how we teach, that a class can only have one attribute or method. Often when we're giving students examples, we try to simplify them. And so they see all these examples with only one attribute or one method, and they think that's kind of the limit. And so just making sure that you're doing a lot of examples with different numbers of attributes or methods. In this case, I would argue this is also a problematic example, because I have exactly 2 attributes and 2 methods. And so thinking about can I have different numbers of attributes or methods? It's unclear from this example. So those are some common misconceptions. It gets really, really messy for students in terms of like, what is really that relationship between the class template and the object, that instance of the class? That's a very, very messy relationship, as well as the variable holding that object and the actual object itself in memory, and doing things like renaming it, copying it. That's also a really messy like relationship. And so anything you can do to show them under the hood what's happening, like the code visualizer, super, super helpful. So evidence-based pedagogy. So today we're going to talk about a couple of things. The first one shouldn't be too unintuitive to you, but live coding. So a lot of times, like what I just did with all those misconceptions, you just show code. Static, here you go. This is the final result. You know, just whipped this up on my lunch break, magically works, no errors, yay. But there is a lot of work when you're going through the process of writing code. There's a lot of skills in that. And so modeling that for them, the process of writing code and its messiness is really important. It has a number of names, but some of the big parts of this is actually verbalizing your thought process. Like, how are you thinking about what you're writing? You can actively probe students, like what should I write? I know I need to do this. What is that in code? Explain the code in the moment as you're going through it. Let the students see you make mistakes. It's a good thing. Even better. +1, if when you make a mistake, you ask for help. So it's one thing to be like, yes, everyone makes mistakes. It's another thing to really normalize asking for help and having someone else help you debug and fix it. If you'd like an example of this, you can see Coding and Train. If you go to this YouTube channel, I think pinned at the top is a compilation of the instructor or the person doing live coding saying whoops as they make mistakes. And so it's just really, really okay to see them mess up. And those debugging skills are just so important. So modeling them is really a great use of class time. It's one of those skills that they're just going to use throughout the year. It is pretty time consuming compared to just showing them an example and tracing it, walking through it. And if you're not really going out of your way to verbalize and prompt the students, it can quickly get unengaging, sort of like being the navigator in paired programming. It's pretty passive if you frame it that way. But you can always do things like, I'm about to run it. What do you think is going to happen? Have students vote on what they think the output is. Anything you can do to keep them involved in that process while live coding and keep it a reasonable length of time. But that modeling is so important. And the other piece of our evidence-based pedagogy today is test-driven development. So code testing often isn't talked about in K-12 CS education. It's generally lightly touched on in higher education, but it's a really important part of producing code that works reliably, is testing your code. So it's used in software development, but basically what happens is before you start writing the actual program that's going to do the thing you want, you're going to write a series of tests that will ensure that when you write the code, when you run that test suite, it does what you want. This is a really great way to kind of force students to start dissecting the prompt before they start writing the code, really starting to understand the nuances of how pieces work together. Again, forces students to break apart the program into small testable parts. Think about what makes each testable part successful and get feedback about the specific part of their program that is not working. Instead of, my code is just completely broken, that test will help narrow it down pretty quickly for them. It does require a number of moving parts. You have the program, the test file, the test runner. And so there's a starter pack for how to kind of streamline this a little bit in Codio so you can play with an example. And so that's it for today. Tomorrow is the last day. We're going to cover the last 2 units, 9 and 10, around inheritance, which is one of those big object-oriented programming concepts, and recursion, which is very, very hard to get your mind around. So we're going to talk about the misconceptions around recursion. And we'll end the week talking about Parsons problems, which are a wonderful way to assess coding abilities very, very quickly.